splitting toes. No one gives a damn about your clothes. Sunday morning, till you dress, you're gonna be your own damn mess. Stage right, stay the night, stage a fight. You gotta make it alright, gotta make it
Good morning, everybody. I'm Eureka John, and you are at Eureka Street Crypto, broadcasting live at 7:02 in the morning on November 27th, 2021. Yep, I'm broadcasting from Leander, Texas, and I do this every single day. If you're catching me on YouTube or Odyssey or BitChute or something like that, I upload these videos every single day. If you're catching me on Spotify, I'm trying to do as much audio up there as possible. However, it is a little bit more of a process to pull out the audio from the videos, and I haven't quite gotten that dialed yet. But I'm still trying to upload as much information and as many episodes as possible to Spotify as well. So yeah, welcome to the show. This is basically my brain dump. And yep, like I said, do it every morning. I'm not sponsored by anybody, and I'm not shilling anything. Just talking about whatever I happen to be learning that day. And yeah, it's been fun, that's for sure. And it's been informative. I've met a lot of really cool people online because of that. And I guess these are my, my COVID era friends, right? This is what making friends looks like nowadays. But I do go outside and I, go skateboarding and skate with some of my in real life friends. I see my neighbors and stuff like that. And anyway, let's move on and let's take a look at the old CoinGecko and see what we have going here. I don't even know why I look at CoinGecko because I don't really do any technical analysis. I don't trade. I don't do anything that really, and maybe whenever things are down, like right now, Bitcoin's down at 54,000. If I have any extra money, which I don't right now because I spent it all on Thanksgiving and Christmas lights, I would put in maybe some, I would double up my dollar cost average type of input, investment, I guess. So but like I said, I don't. And Ethereum hasn't really done much. I mean, it went up to 4,500. It's back down at 4,100. But it's stayed right around this 4,000 mark, which is pretty amazing, And Bitcoin, it's been all the way up at around 60,000. Now it's back down at 54,000. There's been a lot of FUD going on, and really, I mean, in 2 to 3 years, all this stuff, all this FUD that we're hearing, which is fear, uncertainty, and doubt, is going to be completely irrelevant. So the way I'm looking at it, I'm just dollar cost averaging in, as much as I can, as much as I'm financially able to. Gonna ride this out because on a day-to-day basis everything looks crazy and volatile. You zoom out maybe a year and it's not as volatile, it still goes up, and you zoom out a decade and it just looks like a freaking skateboard ramp going straight up, with maybe even some vert on it. I don't know. So so all right, Binance Coin. I don't care about Binance Coin, honestly. Just 603.55. It's basically Binance Coin. If you don't know, Binance is a centralized exchange, and by centralized I mean it is owned and controlled top down. It's not decentralized. It's an exchange. It's not a decentralized market exchange and stuff like that, like Uniswap or something like that. That you plug your wallet in. They own your keys to your crypto and stuff like that. Even though they do have that Binance Smart Chain that's supposed to be decentralized, but it's really owned and controlled. And CZ, he's the CEO, the founder. He could pull that and bend the rules or make change it up any way he wants at any point in time. So, and anyway, I guess you can hear a little bit of bitterness in me. I can't use Binance because I'm in Texas. And I'm in the United States, first of all, and Binance US also is not available to me because I'm in Texas. Regulatory type of stuff, right? Then the Tether's a stable coin. Solana 197.76, Cardano $1.56, down significantly. XRP 95 cents. All right, I don't know why it's still number 7. USDC stable coin. Polkadot 35.43. The Doge, I don't know why it's still number 10, 20 cents. Avalanche is moving on up at 108.39. Shiba Inu, I don't know why it's in number 12, but it is. Crypto.com been making big moves. It has the Staples Center in Los Angeles is going to be named the Crypto.com Center, from what I understand. So that's huge stuff. Crypto.com to me are like the kings of branding in the crypto marketplace. Back when they first started, they bought the domain name crypto.com for some exorbitant amount at the time, and I can't remember it, but it has paid itself back multiple times since they have bought it. And yeah, so Terra Luna, that's a good project. It's number 14. And then so we have Polkadot, and we have, because this is relevant to what I'm talking about, and Cosmos. Let's see where Cosmos is. Where are you, Cosmos? There it is. The Atom is the ticker, ATOM. It's down here number 28 at 27.33. And you know, these two guys are pretty far down here, relatively speaking, for what I believe they're doing. Same thing with Chainlink and Matic as well, in number 18 and 19. Yeah, I think, you know, Polkadot, Cosmos, Chainlink, and Polygon should all be right up near the top, you know, in the top 10, you know, but they're not. And that's because a lot of people are not in it for the tech. Obviously, as you can see, Shiba Inu and Dogecoin up here at the top. They're in it here for pure speculation and whatever looks snazzy and, you know, fancy, you know, whatever some big names, you know, purport to be behind or something like that, and rather than what it's actually doing. And the further I go down the rabbit hole of what a lot of this stuff is doing, I mean, there is totally like a VHS versus beta type of scenario going on. Back in the 80s, I remember this because I was an 80s child, and you know, VHS was the popular videotape recording and playback mechanism in which you could take a movie home and you could put it in your TV in the VCR player, and you could watch that movie at home without going to the movie theater, and it was completely amazing. Then along comes beta as well at the same time, and beta had higher quality video, and it was amazing. And so it became the VHS versus beta war. VHS ended up winning out, even though it wasn't as higher quality, because it was more ubiquitous. It had longer tentacles into the marketplace, and it was making itself more widely known. And yeah, beta just kind of drifted off, sail away, sail away, sail away. And yeah, you didn't hear much about beta anymore. And even though it was, I guess, better technology. So we might see some of this kind of happening in the blockchain world. But I don't know. I'm not saying that, you know, because I believe that Polkadot and Cosmos are in a way blockchain 3.0. Are we talking about Web 3.0? Polkadot and Cardano are blockchain 3.0, where Ethereum would be blockchain 2.0, and Bitcoin, of course, blockchain 1.0. And I'll explain some of this here in just a second with some of these articles that I've been exploring. And so might as well let's go there now. So all right. So let's see. What am I reading up on here? I got like a million articles in preparation for different things I'm going to talk about. Okay, so I saw this article here. Let me make sure that all this pulls up well on the screen. Okay. All right. Good. Very good. All right. The war on virtual machines, WASM versus EVM. What is WASM? WebAssembly machine or something like that. All right, versus EVM, Ethereum virtual machine. All right, and here's this guy from Game of Thrones, I believe. I only got like a couple seasons into Game of Thrones because then the screen started getting real dark and I couldn't see what was going on, and I just felt like an old person. I'm not really super into that type of show, but I was just like, I can't see the dang screen, it's so dark, I can't see what's going on. So I kind of lost interest, and anyway. Yeah. All right, so what is Ethereum virtual machine? It says WebAssembly is coming, brace yourself, using the brace symbols. It's total nerd tech humor, and I'm only partially nerd tech type of guy. So yeah. All right, so what is Ethereum Virtual Machine? Ethereum Virtual Machine is a lightweight virtual machine that is designed to run various smart contracts on the Ethereum network. Ethereum EVM, Ethereum Virtual Machines, we'll just call it EVM from now on, functions differently on traditional operating systems such as Windows that can only run on one machine at a time. So think about your Windows program, your iOS, or whatever's running on your computer, and it runs only on that machine. So yeah, it can't run on multiple machines at a time. So the Ethereum virtual machine is basically a computer written into the code on the Ethereum blockchain that allows it to run anywhere and everywhere all at the same time, wherever somebody is running a node. And wherever an Ethereum computation can be done, that's the Ethereum virtual machine. And you look at all these smart contracts like Aave for decentralized finance. That's one example, and it's running code in order to be able to run those smart contracts. And it's running it basically everywhere because there are thousands and thousands of Ethereum nodes, and there's just by node I mean a computer that is storing and doing computation for the Ethereum blockchain. And whenever you submit a smart contract on an Ethereum machine, some kind of node is running that, and it has to go around to all the different nodes to make sure that every single computer that is running that very same program is coming up with the same answer. Then they come to consensus, and then that's whenever that can be added to the block, and that's what makes a blockchain. So the Ethereum virtual machine is the code running all that, the computer running all that, the operating system running all that. So in Ethereum, an EVM is a high-level abstraction built on a native operating system to emulate a physical machine. So yeah, it's this kind of weird spiritual computational layer. So with an EVM, the same platform can run on many different operating systems and hardware architectures. This makes virtual machines suitable for networks such as Ethereum that are basically accessible through various clients on different machines distributed all over the world, like those nodes I was talking about, the validator nodes. So there are thousands of them. So this feature of being able to run on different operating systems, because you never know what you're going to get with operating systems and hardware architectures. Somebody might be running Mac. Somebody else might be running Windows. Somebody might be running Linux, or something that they made up. I don't know. But it makes VMs suitable for networks such as Ethereum that are accessible through various clients on different machines distributed all over the world. And EVM can emulate the functions that can be done on a physical CPU, and is responsible for most of the functions on the Ethereum network. So anything that can be done on your central processing unit, which is your chip in the middle of your machine, it's the heart of your machine, and it's responsible for anything. An Ethereum virtual machine can do anything that can do, and is responsible for most everything on the Ethereum network. So it has the following characteristics. Determinism. Determinism program gives the same outputs to the same set of inputs, irrespective of the number of times it executes the same code. So no matter how many times you put that same thing, it's like the definition of craziness. If you're doing something negative or terrible for you, if you keep doing it and expecting a different output, you're kind of crazy. But in Ethereum's case, that's good. It's determinism. It's deterministic. In Ethereum, dApps deal with millions of dollars at a time, and various users need to know how the code reacts at every stage of its execution. They need a deterministic output. They need to know exactly what's going to happen. And then it's isolated. Smart contracts need to run in completely isolated environments. This ensures that if a hack or bug happens to a smart contract, it will not affect the rest of that underlying protocol. It needs to be isolated. And then terminable. And this is one I kind of got hung up on because of the language, but I ended up going a little bit down the rabbit hole. So Ethereum smart contracts are Turing complete. Therefore, they should be in a position to solve any problem given enough time and resources. Smart contracts should come with a terminating mechanism because it is hard to determine if a contract will finish all of its operations within a given time limit or not. Ethereum uses the gas limit to terminate contracts that exceed execution limits. So I've always thought that the gas was there to avoid denial of service attacks, which is when some kind of bot or malicious actor pings an API or a web form or something like that, hundreds of thousands or thousands of times in order to try to crash the server and destroy the website. And that is one use of gas. But I didn't realize that the use of gas limit is to be able to have some kind of termination limit on the smart contracts, because whenever you're doing computation in an Ethereum smart contract and you're running that, have you ever sat there and you've run some kind of staking? You try to stake your tokens up on some kind of decentralized finance application, and it's just taking forever and forever and forever. Well, if there's no gas limit, that will just go on and on and on and on if it's caught in a loop. And the gas limit, what happens is all that computation is costing gas and gas. And then what you do is whenever you're running and you start that in MetaMask, for instance, if you're entering in the amount of gas you will pay at a max in MetaMask, called the gas limit, and when it hits that, it has an outside thing telling that loop to stop. And that's what, so Turing complete, Alan Turing, back in, I believe, World War II or something, created this Turing complete computer that was kind of an overarching computer that allowed any type of computation to be solved within this umbrella. So any type of computation you could ever dream up in a Turing complete computer, it can be done. And it's a great thing, and it was an amazing invention. Too bad that the people at the time couldn't handle who he was, and did bad things to him because he was gay, which is lame. And then they end up basically executing him. So yeah, man. There's geniuses in the world that are completely misunderstood at the time, and it sucks sometimes they're born a few decades too early. But anyway. Regardless of all that, he created something incredible. He created a Turing complete machine, so you could basically plug in any single type of computation in there, and it can be done mathematically. However, the problem with that is there are loops in computer programs, and loops will go on indefinitely. They'll just keep on going until some kind of outside mechanism will pop in and tell it to stop. And if there is no outside mechanism to keep doing that, it'll keep going and keep going and keep going until basically the computer just runs out, because math doesn't get tired. Computers might get a little tired, and then it'll crash the computer, or it'll be running a program that you can't stop and you can't move on and do anything else. So that's why Turing incomplete is sometimes important in blockchain applications. Bitcoin is Turing incomplete. That doesn't include these types of loops, and so it keeps it lean. But Ethereum is Turing complete, so that's why they have to have the gas limit in there. And I was just like, wow, man, you know what? You learn something new every single day in this space, don't you? So yeah, so yeah, so I think I just find that okay. I don't know. See, that's why I do this, to try to externalize what I'm learning. So I'm listening to how I'm trying to explain this. I understood it in my head. Okay, so okay. All right, so it's terminable. Ethereum smart contracts are Turing complete, therefore they should be in a position to solve any problem given enough time and resources. Smart contracts should come with a terminating mechanism because it is hard to determine if a contract will finish all of its operation within a given time limit or not. Ethereum uses the gas limit to terminate smart contracts that exceed execution limits. Okay, and then it is the decentralized processing unit of the functions of Ethereum virtual machine. So what are the functions of Ethereum virtual machine? Okay, it's the decentralized processing unit of the Ethereum network. So it's the central processing unit in a computer, that main microchip, the heart of the computer, or the brain of the computer, actually. In Ethereum, it's all decentralized. It's everywhere, everywhere in every computer that is running Ethereum. So it's the decentralized processing unit of the Ethereum network. Every interaction, transaction, and smart contract execution can only happen here. And then another function is it fetches and executes instructions and decodes operands through a given instruction dispatcher. So in the previous episodes, I've been talking about modular versus monolithic blockchains, and then modular versus monolithic chips, and then AMD versus Intel. Intel has this big one block of silicon that would do all this stuff in one chip, but according to Moore's law, the amount of transistors doubles every single year, and you get to the point where it physically can't handle that amount of transistors. So it was running to a point where Moore's law was starting to cave in on itself. So AMD came in and revolutionized it and created a little central type of router on the chip, and then all these smaller chips around it that would handle all the not transactions, but the computations and stuff like that, in order to break up that into little modules, and that would allow everything to function and keep that law continue going and going. And that's where all the fetching and execution and decoding happens through a given instruction dispatcher. And on an Ethereum virtual machine, that same thing, is now happening. It's being broken up into modules. So another function of EVM is responsible for all data structures, such as operands, data processing instructions. Another function of EVM is keeping track of network components, such as storage state, block information, or world state. And then one more is responsible for creation of a runtime environment for different smart contracts on the Ethereum network, because those smart contracts have to have a place to be run, so the Ethereum virtual machine provides that place to run. So it's very important, all this stuff, and what would normally be handled in a CPU, the Ethereum virtual machine is handling on tons of computers worldwide, and it has to have some kind of universal place to do it, a universal framework within which to do that, because of all the variety of different operating systems and architectures. All right, so the challenges with EVM, it's not fast. Think of all the different architectures and operating systems that it has to deal with, and EVM processes so many different and diverse operations, but its opcode specifications haven't evolved to handle all those varying needs. I mean, you can't make everybody happy, right? So failure to evolve means that the languages are also limited. So in comes WebAssembly language, or WebAssembly language. So WebAssembly language is a new type of code that executes on modern browsers efficiently. This new code is created and defined by the World Wide Web Consortium. If you've ever developed a website with code, not a little, WYSIWYG, what you see is what you get type of thing, drag and drop, WordPress or whatever. If you've ever actually gone into the code and tried to create a W3C compliant website by hand using Notepad, you're familiar with the World Wide Web Consortium. It's a great place to learn web development too. Anyway, so this was WebAssembly is a new type of code that executes on modern browsers efficiently. And WebAssembly was designed to work across all different types of browsers, because whenever you're a web developer, you want it to work just as good on Opera as it does on Microsoft Edge, as it does on Brave, so as it does on Firefox. And as it does on mobile, there's all these tiny little quirks, you're like, oh man, and you see these little disclaimers, this website, may have some bugs and issues on, it's getting to be less and less of a problem nowadays, but because of WebAssembly language, I think. So anyway, this new code is developed and defined by the World Wide Web Consortium. Why can't I have trouble saying that? WASM is WebAssembly Language for short. It's the acronym. Is built for web and involves engineers from Google, Mozilla, and Apple. Essentially, WASM is often referred to as Ethereum 2.0, and has all the functionalities of EVM and comes with extras. So it's built for the web. As already stated, various engineers from big technology companies such as Google, Microsoft, and Apple are part of the development team. Such engineers are thus ensuring that WASM is compatible with their engines and protocols. Designed with a specific set of goals in mind, WASM is created to be fast, efficient, and portable. It will take advantage of common hardware capacities to execute at near-native speeds. It's designed to be easily readable and debuggable. It comes with a text format that's readable by humans. The code can be viewed, written, and debugged by hand. And it's designed to be secure. It enhances the host browser's permission policies and maintains backward compatibilities. So, all right. So EVM, Ethereum Virtual Machine versus WASM. Simply put, Ethereum Virtual Machine is the jackass of all trades, master of none. How EVM deals with compilation is a perfect example of this point. So what is compilation? And, because I don't assume that everybody has even an inkling, a twinkle in their daddy's eye of what compilation is and any type of programming type of knowledge, because I haven't had the type of. So a compiler is a computer program that translates computer code written in one programming language, the source language, into another language, the target language. So the name compiler is primarily used for programs that translate source code from a high-level programming language, which means basically close to English, to language to a lower level programming language, which basically is ones and zeros. All right. So that was to me opposite. Because you normally think something that's really high level is really super advanced. In the computer world, it's flip flopped, or in business world, I guess too. But basically, high level means kind of an overview, like you're looking down on the parade from the top of the hill, and you just see everything. And you're like, oh wow, I spot a terrorist over there. But when you're down in the low level, you're actually in the crowd, and there's advantages to both, right? So neither one is better than the other. So back to the article. So the compiler is the one that translates a high level language into a very low level functional practical type of language that can be used. So how EVM deals with compilation is a perfect example of it being the jackass of all trades but master of none. The native engine struggles with finding the optimal path for executing certain operations, eventually affecting EVM's overall throughput. EVM can only process 256-bit bytecodes, which means that that anything smaller than 256 has got to be converted to 256-bit format before being fed to EVM. The scalability issue of EVM is apparent as it only processes 25 transactions per second. And if you're trying to run a metaverse or even a bank account on something like that, it gets a little sticky, as you can see. Sticky meaning moving real slow. You ever had that dream where you're just like, you're trying to run fast, but you just can only run so fast, and it's so frustrating. And or you're trying to fight, but you just roar, anyways, I digress. So WASM transitions directly into compiled code, which enables it to load faster at the same time, increasing the number of transactions processed by each block. So EVM only processes 25 transactions per second because it has to compile it and convert it first. WASM, it goes directly into compiled code, which enables it to load faster and increases the number of transactions processed for each block. So and that affects block time, which affects the speed. So the amount of time Ethereum has to sit around at the bus stop waiting for it to be loaded affects that. And WASM, it doesn't have to sit around waiting for it to be loaded. So EVM relies. It's like when you're at the New York subway, and there's always that person that's going to try to sit there and just shove their foot in right as the door is closing, and then boom, boom, whatever, and then the door's closing, then it starts to open because somebody's foot just plops straight in the middle, and then it opens back up, and everybody on the car is like, oh god, because they just want to get going, So and that's the compiler, I guess. That's a terrible analogy, but anyway, so EVM relies on precompiled contracts. So that's Ethereum virtual machine. It relies on these precompiled contracts. So when a call for a precompile is issued, the EVM will execute a predefined native code and then present the results. These precompiles are specific to a certain protocol for the basic operations, such as signature schemes and hashes. Okay, even though precompiles make cryptographic computations efficient without consuming loads of gas, they come with issues. The introduction of precompiles usually demands the network to undergo a system-wide hard fork. So they have all these precompiled functions in there that have already been translated, that are sitting in the Ethereum virtual machine smart contracts. But that makes it pretty efficient, and it doesn't use a lot of gas. But anytime you want to bring in a new one, because things innovate, you basically have to completely hard fork, which is create a completely new blockchain, which sucks, especially if you've had forks are basically when how am I going to try to articulate? Forks are whenever some kind of change has happened that an entirely new blockchain is created off of that. WASM eliminates Ethereum's reliance on precompiled contracts. So because WASM is so gas efficient developers can create smart contracts that are efficient and fast without worrying about potential hard forks. All right, so cool. So WASM supports more languages. It comes with an extensive set of tools, more extensive set of tools than Ethereum Virtual Machine. WASM supports traditional language such as Rust, C, and C++. WASM is also supported by native JavaScript engines such as Google's V8 engines, that's in Node.js and Chromium-based browsers such as Google Chrome, Microsoft's Chakra engine, which is Edge. I didn't know anybody used Edge, except for grandma. And Mozilla's SpiderMonkey engine, Thunderbird, and Firefox. So I wonder, yeah. So okay. And then the funny little meme. I don't know what WebAssembly is, and at this point, I'm too afraid to ask. So Ethereum introduced certain capabilities that were unavailable on the Bitcoin blockchain. Bitcoin blockchain, like I said, is blockchain 1.0. All right, and then the introduction of Ethereum Virtual Machine allowed developers to create and deploy smart contracts with ease. So that's blockchain 2.0. And then, however, Ethereum Virtual Machine has many limitations that WASM is trying to solve, according to webassembly.org. WebAssembly 1.0 has already been shipped to 4 major browsers. So yeah, and then I went over here to the WebAssembly website, and yeah, it has all the 4 main browser logos. And then Cosmos is doing a lot of work and running WASM, and which is the Cosmos WebAssembly language, and it can run on multiple chains, allowing their IBC, the Inter-Blockchain Communication Protocol, to function. And you can go over here to cosmwasm.com, COSMWASM.com, and learn more about that. So it's not just going to be Ethereum only from now on. This is why I say a lot of these ETH killers are not going to be killers, but everything's going to be starting to converge all into the same space and all be usable. So now there's another article here announcing the launch of WASM by Michelle Leach, and it talks more about this. It says adding WebAssembly to the Cosmos SDK software development kit allows software in many languages to run securely on a blockchain. WASM serves as an intermediate language that compiles the developer's language of choice into a portable virtual machine. So WebAssembly code is naturally larger than Ethereum bytecode as it offers more generality. So yeah, it's definitely more universality. So while the ecosystem, the Cosmos ecosystem, is still nascent, the smart contract environment within WASM is Turing complete. There's that Turing complete. This means that you have the capability to perform any logic that could be implemented in Ethereum and execute it within the Cosmos SDK without modifying the underlying blockchain. So that's pretty helpful. And then I found this website over here, talked about, Parity. All right, so Parity, they're the builders of Polkadot, right? And so the blockchain infrastructure for the decentralized web, from the substrate blockchain framework to Polkadot, the sharded protocol enabling blockchains to operate seamlessly together at scale, Parity builds the foundation of Web 3.0. So what is this? And here they in this blog article, they have a WASM smart contract development. Why we believe in WASM as the base layer of a decentralized application development and not EVM. And I know a lot of these other blockchains are sitting there like Theta, Zilliqa, all these are becoming EVM compatible. And I say repeatedly, Ethereum is the king because all roads lead to Rome. All these blockchains bridge to Ethereum and are becoming EVM compatible. And that's what this means. They might have WASM or they might have some other way to do things, but they have to become EVM compatible because Ethereum is the king. And this leads back to the whole, VHS versus beta thing. Which one is better? However, in this case, I don't think that WASM is just going to fly away into the distance, sail away. So why we believe WASM as the base layer of decentralized application development. So the issues with the current tech. Ethereum pioneered the field of decentralized application platforms with the introduction of EVM, Ethereum's runtime environment for smart contracts. So while at the time there was good reason to build a custom EVM easily integratable into a blockchain, there are serious issues with that approach. And here they talk about the whole 256 thing and the whole compiling thing. The EVM is inefficient, that it doesn't support integers smaller than 256 bit, and any 256 bit has to be performed by CPU with multiple 64 or 32 bit operations. There's also few people capable and available to expand on EVM and the needed tooling. So all this is to me now I'm understanding the merge between Ethereum 1.0 and 2.0 a little bit better now too, because they're trying to fix these limitations of the original Ethereum virtual machine. So WebAssembly, a highly supported high performance standard. So they believe that WebAssembly and the multitude of languages that compile to WASM are an ideal alternative to EVM. So WASM is a standard for web browsers developed by the W3C work group that includes Google, Mozilla, and others. It was developed so that the code can be deployed on any browser with the same result. WASM is high performance. It's built to be as close to native machine code as possible while still being platform independent. So yeah, it facilitates small binaries, smaller than 256, to ship over the internet to devices with potentially slow internet connection. And there's been many years of work put into WASM by both by compiler and standardization teams. So what language would you like to write your smart contract in? And most importantly, WASM expands the family of languages available to smart contract developers, including Rust, C, C++, C#, TypeScript, HAX, and Kotlin. Now, this means you can write smart contracts in whatever language you're familiar with. So any of these smart, insanely smart software developers can jump in and start doing this stuff in the Web 3.0 space. Right. So there's more technical stuff here, but the road to WASM support. While WASM itself benefits from wide support and integration, unlike EVM, it is not built with the purpose of interacting with the blockchain. So Ethereum virtual machine was made to interact with Ethereum. WASM was not. It's made for browser interoperability. So right now they're testing WASM on the Kovan testnet, on which Ethereum virtual machine and WASM smart contracts can coexist and even interact with each other. And that's what I'm talking about, all these bridges back and forth between, Cosmos has an Ethereum bridge, Polkadot has an Ethereum bridge. They are all bridging and EVM compatible. That's what this means. So, because we believe in WASM to be the foundation, this article was written by Parity, which is Polkadot. It's just like you have the Ethereum Foundation, you have off-chain labs building Arbitrum. There's always some kind of, you have the ECC that builds Zcash. It's all these projects are decentralized and they are not owned by anybody. They're open, so anybody can do stuff on them. But there's labs and companies that are developing these. So because we believe WASM to be the foundation of decentralized system development, Polkadot, a next generation blockchain interoperability protocol, is being built with WASM support from the ground up. Polkadot smart contracts will be able to be developed in any language that compiles to WASM. So yeah, I think WASM is going to be blockchain 3.0, and right here it says they're building WASM on Kovan testnet, on which EVM and WASM smart contracts can coexist and even interact. So I don't think that EVM is going to be blockbustered. It's all going to become able to start talking to each other, and be one big happy blockchain family on blockchain 3.0. So yeah, anyway, hope you enjoyed this. Give it a thumbs up or whatever. I don't really look at stats all that much, but it does help. I mean, it makes me feel good, right? When I get thumbs up. And I've gotten a few thumbs downs lately, and whatever, that happens because of my Zcash video, and people didn't like the idea of Zcash go on proof of stake and stuff like that. And that's not my fault. I didn't make that decision to go proof of stake with Zcash. I just talk about it, or maybe I didn't explain it well. I don't know. But yeah, I will talk to you guys as per usual tomorrow. And hit me up on my Twitter, Eureka John, the number 1. So at Eureka John 1, the number 1. And somebody else had Eureka John, and that sucks. So oh well, maybe I don't know. All right, I will talk to you guys tomorrow.